Greetings everyone, I'm Parjanya Pandey and this is the first video log of the subject Systems and Network Security. In this video log, we are going to talk about switchboard security and DHCP configuration. So let's start with switchboard security first. What is switchboard security? It is a feature that allows network administrators to control which devices are allowed to connect to a specific switchboard. It is needed to prevent unauthorized access to the network, protect against potential security threats, and ensure network performance and stability. It allows administrators to limit the number of devices that can connect to a port and detect any attempts to connect to unauthorized devices. Let us understand this by an example as presented here. So we have a central switch here, which has three ports and it is connected to three different devices. Now the administrator has applied some security measures in here, the switchboard security, which says that for the port FA01, it only allows the MAC address of PC1. And as PC1 is connected to the port, we can see that the communication happens smoothly. Same for the second port, FA02. It only allows the MAC address of PC2, which is also connected, so the communication happens smoothly. Now, as for FA03, it allows the MAC address of the third PC or PC3, but an attacker is connected to the port FA03, so the communication does not happen. This is how switchboard security helps us to prevent unauthorized access into the network. Having talked about how switchboard security works, let us see a practical demonstration of switchboard security in the Cisco Packet Tracer. So here we have opened Cisco Packet Tracer and I'll first select a switch to work on and I'll zoom in. And I'll select 4 different end PCs or end devices to work on. And we'll connect these 4 devices via a straight cable. And since switch takes 30 seconds to connect to each of the devices, we're going to use this button to skip that time so that we don't waste time on waiting. So now that we have connected 4 devices, we'll first have to manually assign an IP to each of the devices in order to establish communication between each one of them. So I'll give them an IP. So we have now assigned IP address to each one of the PCs that we had. And if I go into any of the PCs and I try to ping, let's say the second PC, you can see that we have replies coming in. So this means that the communication is happening successfully and the switch is working correctly. So now let's go into the switch, go into the command line interface, and I'll go to the enable mode and let's see the MAC address table that we have. So as you can see here, we have all the 4 ports and the type of the port is currently dynamic and we have MAC addresses corresponding to each of the ports. So the PC connected to FA01 has a MAC address as the following MAC address and so on. So what we'll do in this tutorial is for the port FA01, we'll assign the currently connected PC, which is this one, to be able to communicate on this port. Any other PC which we connect except from this PC would not be able to communicate and the port will shut down immediately. So for us to set up this, let's first go into the configuration terminal and we'll go into the interface FA01, which is this interface. And the first thing that we'll need to do is enter switch port mode access. Essentially, there are 3 modes: dynamic, access, and trunk. Trunk allows us to pass traffic for multiple VLANs, while access allows us to pass traffic for a single VLAN. Essentially, trunk is used to connect multiple switches to one another, while access is used to connect endpoint devices. So we'll change the mode from dynamic to static, and then we'll apply switchboard port security. We'll say that the MAC address that we need to enable is this one. We'll copy this and we'll paste this here. And finally, the violation of any of the different MAC address would be shut down. So if I go into do show running and show running configuration for a switch, you can see that for the interface fast Ethernet 0/1, we have applied access mode, the port security is enabled, and we have also enabled a MAC address on this port to communicate. So if we now see the MAC address table, you can see the type is now static for the port FA0/1. Now that this is established, let me disconnect this port and connect it to any other port, and we'll connect the second PC to the port FA0/1. I'll skip the waiting time and now disconnected. So now I'll go to the second PC. I'll open the command prompt and I'll enter ping 192.168.1.1. So we'll try to communicate to this PC using this PC using the port FA0/1. And as soon as I press enter, you can see the port goes down. This is because it is a violation. The MAC address is not registered with the switch, so the port shuts down automatically. If we go into the switch, we can see that the interface changed state to administratively down, and the state is down now. Now, if we want to make the port up back again, it's not a simple disconnection and reconnection. Because as you can see, I can connect the PC that we allowed to the port, and it's still not connected. The port is still down. What we need to do is we need to go into the interface. I'm currently in the interface as well. So I'll shut it down manually, and then I'll enter no shut. So after entering no shut, the port is back up again. And if I show you, I can use this port again. I'm sorry. I can go into the command prompt and I can use this port again to get replies and communicate again. So the MAC address is stored in the switch, and we can use the MAC address of this PC to communicate to any other PC. Now let's say this was one of the examples where we can enter a MAC address manually, but if we have loads and loads of PCs in our network, we can't enter each and every MAC address manually. I suppose we have to change the devices on a port frequently. We can't every time change the MAC address on each port. For that purposes, we have one attribute which is known as sticky. So let me exit this interface and we'll configure some other interface. So FA02, and in this interface, I'll do it again. Switch port mode access, switch port security, and then port security MAC address. And here, as you can see, there's an option of sticky. So we'll enter sticky as the MAC address, and the maximum number of MAC addresses we want is 2. So we'll enter that, and we'll enter a violation of shutdown. And if I show you the running configurations now, for second one, we have the mode access, port security enabled. The maximum MAC addresses allowed is 2, and the MAC address is sticky. So what happens now is, if I use any of these PCs, essentially if I use this PC to communicate now, and I'll say ping 192.168.1.1, it gets me a reply. And apart from that, if I go into this switch again and I see the running configuration, it stores the MAC address of the PC that I used to communicate now. So what I'll do is I'll disconnect this PC, I'll connect it to some other port, and I'll use third PC to communicate on the port FA02. And now I'll use this PC to ping the first PC, which is this one. So now you can see we get the replies as well. And in the switch, if we go do show running, it has stored 2 different MAC addresses of 2 different PCs, as we have entered the maximum number of MAC addresses to be 2. So it automatically gets the MAC addresses which are connected in sequence or in serial. So now if I disconnect this PC again, I connect it to its designated port, and I connect the fourth PC, which is not registered with the switch, to the second port, and I try to now ping using this PC. So as soon as I press enter, you can see the port goes down because we have not registered the third MAC address, so it stops on 2, and for the third MAC address, it just goes down. So as you can see here, the state is changed to down, and FA02 is administratively down. So this is how you can support multiple PCs to be connected in sequence, and thus you don't have to enter a MAC address each and every time you set up port security. So this was how you can do switch port security, and I hope you understood it quite well. Next, we'll talk about DHCP configuration. Essentially, what we did now was we entered the MAC addresses manually in each of the PCs. DHCP helps us to prevent that. Let's see about that more in detail in the presentation first. So, DHCP configuration is a network protocol that automates the process of assigning IP addresses and other network configuration information to devices on a network. It is needed to simplify the network administration process and ensure efficient and reliable network connectivity. It eliminates the need for manual IP address assignments and helps us to prevent conflicts between devices that share the same IP address. It allows for easier network management and reduces the risk of errors that can occur with manual configuration of IP addresses. DHCP configuration essentially uses a four-step process which is known as DORA process, or as you can see in this diagram. Essentially, a client, when first comes into the network, it sends a discover request into the network. It broadcasts a request so that it can discover if any DHCP server is present in the network or not. Then multiple DHCP servers might be present in the network. Each of them sends an offer to the client regarding what IP pools that are present and what they can offer to the client. The client then sends a request again to a DHCP server, a particular DHCP server, saying that I want your IP address, I want IP address at this range, and finally the DHCP server acknowledges the request and gives an IP address to the client. So this is how DHCP configuration happens, and a client is automatically assigned an IP address in a given pool. So now let us see how this can be done in Cisco Packet Tracer. We'll demonstrate in there. So I'll delete all of the previous things and I'll make a new, I'll set up a switch. I'll have a router and we'll have some devices. Let's set the devices this way. I'll use straight cable to connect each one of them. And as you can see now that the router is in permanently shut down state. That is because in a router, we first need to say no to the initial configuration, go into the enable board, configuration terminal, and we have used the FA0/0 port. So in the FA0/0 port, we'll have to say no shut, then only it goes up. Now we'll also assign an IP address of 192.168.1.1 and then network mask of 255.255.255.0 to the router. And essentially we have given an IP address to the router. So now you can see if I have here, the VLAN one, the FA0/0 address is 192.168.1.1. So now that we have assigned an IP address to the router, let us configure the DHCP server now. So I'll go into the configuration terminal. I'll go IP DHCP and we have several different options here. So first we need to exclude some addresses which we don't want to give to the PCs or the endpoint devices in the DHCP network. So I'll add exclude addresses, and since we don't want 1.1, which is the IP address of the router, so we'll add this address, and let's say we have a DNS server as well. So I'll add that address as well, separated to the space, and press enter. So these two addresses are excluded and these won't be given by the router to any of the PCs. Now we'll say IP DHCP pool and we'll give a pool name. For this tutorial's purpose, we'll state the pool name as SNS. As soon as I press enter, we'll go into the DHCP configuration of this pool. So we have different commands here. First one is the network. So we'll specify the network in which we want to give the DHCP pool. So that is 192.168.1.0. That's the network ID and the network mask that we have to provide to 255.255.255.0. Now we can have a default router as well, which we specified to each of the PCs. That is the default gateway. It does 192.168.1.1. And we also can set a DNS server, as I said. So that let me set that as well to 1.2. And this was the work that we had to do in order to set up our DHCP server. Now we can simply exit and the work is done. Now, if we go into the PC, we go into desktop, IP configuration. Instead of static, we go into DHCP. It requests an IP address and the DHCP request is successful. And as we said, we had to skip 192.1.1 and 192.168.1.2. So it starts the IP address with 192.168.1.3. We have the network ID. The default gateway as we specified was 1.1. The DNS we specified was 1.2. So each of them is provided. Let me go to the next PC and do it again. And it is again successful. We get 1.4. And finally, in the last PC, if we go in and we go DHCP, so yeah, so we get 1.5 with all the configurations that we had set up. We can also set up a DNS server if we want to. It is pretty easy to do. You can just specify a straight cable and we can connect it. In the server, we can just show services, we can turn on DNS, we can enter names and the addresses which we want to connect to. We can add the addresses, it's an A record. So essentially that is what we can do in the setting up of DHCP servers. Hope you liked the video. This was Parjanay Pandey talking about how we can enable switchport security as well as how we can configure DHCP servers on our router. Hope you liked the video. Thank you.